Okay. So again, we want to know if these are permutations or combinations, right? Remember, for a permutation, the order matters. If you change, if you change the order, you do get a different, the order matters, in other words. So here we have 8 basketball players, right? And they want to choose a captain and a co-captain. Okay, well, that's going to be a permutation. The first person they choose might be the captain, and then they'll choose the co-captain. They're choosing different people for different roles. It's kind of like that other one I think we did with an election, if I remember correctly. There was a president, vice president, I think a secretary, but we saw that order mattered there. So here, order does matter. So here, the order does matter. And because the order matters, it's a permutation. Number 1. Let me write that down. Nope. There we go. Okay. I tried writing on this with the whiteboard feature in Blackboard, but I really don't like it, so I'm using Microsoft Whiteboard, and hopefully that's better. So we have a permutation there. Okay, now how many permutations are there? Well, if you go back to our notation, we have P of 8, right? There's 8 players, then they're choosing 2 of them. One's going to be the captain, one's going to be the co-captain. The order matters since those roles are not the same. Now, how many is that? Let me see, what's my notes? Here we go. That turns out to be 56. So, I used my Desmos. I used Desmos for this, the calculator. I think I showed you guys that. You get 56. Okay. Right, there are 8 players and you're choosing 2 of them. Okay. All right, let me do number 2, which is the next one. Again, this worksheet I did email, so you have it in front of you. Well, I mean, in your inbox if you didn't get it yet. Okay, so for this one, we have 2 people, Rob and Mary, right? They're planning trips to 9 countries this year, okay? There are 13 countries they want to visit, but they're deciding which ones to skip. Right, so that means they're choosing of the 9 countries, they have to decide on, of the 13 countries, excuse me, they need to decide which 4 they're going to skip. Okay? That's what they have to decide. What the? Oh, okay. Sorry, I thought something went weird with the Blackboard here, but it's fine now. But okay, so they have to decide which 4 to skip. But does the order matter there, though? So when you're deciding which countries to skip, if you're planning a trip, does the order matter? In that case, well, I think the answer is no. They're deciding which ones they're going to skip, but that's not going to make a difference. They're planning a trip. The order in which they skip the countries doesn't make a difference. So for this one, we get a combination since the order doesn't matter. Combination. And so here you have 13 countries, right? They're skipping 4 of them. And I don't remember what that number is, but let me take a look. I think that number turns out to be pretty big, actually. Oh, it's not terrible. It's 715. Here, let me get to that. So it turns out to be about 715. Okay, that's cool. That was fun. The next one below, let me zoom out a bit. For the next one down here, what the? Okay. Bear with me. Here we go. Here we go. Now let me zoom in. I had to zoom out to move in and all that stuff. But anyway, for the batting order, you have 7 players on a 12-person team, right? Okay, well, for batting order, does order matter? Anyone? For batting order, would the order make a difference in the lineup? Yeah, of course it does, right? The batting order is going to make a difference. Well, since order matters, that tells us we have a permutation. So that tells us then that we have a wonderful permutation. Let me write down now. But now the question is, how many do we have? Well, let me write that down. We have P of, let's see, there's 12 people. You want to get 7, right? You have 12 and you want to get 7. But now how many is that? Well, I did this through a calculator. And where is it? Oh, there it is. Well, that's a big number. Turns out to be pretty big, actually. About, let me see if I can write it. 3,991,680. Again, order matters. That's why it's pretty darn big. All right, that's cool. Let me just it's over here. Now for the next one, bear with me. I just gotta, oh boy. Here we go. Finally. Okay. So for the next one, you have these 45 applicants for 3 computer programming positions. Okay, so they have to choose 3 applicants. It doesn't matter what order we choose them in. I mean, I would say no. Right? They're all applying for the same job. Right? So you're choosing 3 people for 3 of the same for the same job, basically. 3 openings for the same job, if that makes sense. The order in which they pick them is not going to make a difference. You know, it's not like with the co-captain and captain, right? The order does make a difference there because the person you choose first would be the captain, and the next person would be a different role. But here, all 3 people are going to basically be the same role, computer programmer. So here we have a combination. Okay, that's cool. Well, oh, here we go. Hey, bear with me. Microsoft Whiteboard, everyone. Okay, so for a combination, how many do we have? We have, well, we're going to have 45, but we're choosing 3. And how many is that? That turns out to be, wow, pretty big. 14,000. What the? 14,190. There we go. 14,000. Wait, you can't see that. Hold on, let me just move this. Oh my goodness gracious. There we go. 14,190. So that is what we get here. Okay, that's good. All right. Now, I also did 5, 6, and 8 with the other class as well. So let's do that together, okay? Okay, so for number 5, you have these 2 people, okay? As you can see, they're planning trips to 3 countries, you know, this year. There's 7 countries they want to visit, okay? Now, one of the trips will be a week long, right? Another one is 2 days, and the other one is 2 weeks. So out of the 7 countries, they're planning these 3 trips, right? One trip, I'm guessing, to each country. Actually, does it say that? No, it doesn't say that. Oh, no, 3 countries. Okay. Well, does it matter what order they decide to visit the countries? Well, notice that the trips are different in length, right? Since the trips are different in length, what one trip they're going to visit one country, right? That's a week long, but the next trip is only 2 days. So the next country they visit, is going to be on a different trip, it looks like. In other words, order does matter here. Mostly because the trip length is not, mostly because each trip is different in length. So the order in which they visit the countries does make a difference. Because again, the trip length is different. The country they visit first, they're going to see longer than the second country they visit. So for this one, we have a permutation. Can you guys see that? Oh, there it goes. I got nervous. I thought it wasn't syncing. There it goes. Permutation. Okay. Well, there's 7 countries, right? And they want to see 3 of them. Okay. There's 7 countries. They want to see 3. Let's see. Oh, here it is. Yeah. So that would be 210. So order does matter because again, the trip length is not the same. So the first trip is longer than the second trip, and the third trip is even longer, 2 weeks. So the order does matter. All right. Let me just ask something. Are there any questions? Or remember, they're planning trips that they're only going to see 3 countries, right? They're taking 3 trips. So the trips are different in length. That's why order makes a difference here. So for the next one, you have 110 people at a meeting, right? They each are shaking hands with everyone else. And they want to know how many handshakes are there. Well, first we got to see, does order matter here? So let's see. Let me do another poll. Okay, so this is for number 6 now. So if you have 110 people and everyone's going to shake hands with everyone else, you want to know how many handshakes there are, but does order make a difference here? Well, as long as you shake hands with everyone, that's what matters, right? But the order doesn't make a difference. Right, so the answer would be no.